Hi, this is Maggie. In this video, we're going to talk about recursion, and our examples will be in Java. Recursion is a form of iteration in which a method calls itself. There are specific ways that you design a recursive solution to solve a problem. Let's begin with an example that might be familiar from real-life experience, a simplified game of solitaire blackjack, or 21. We'll represent the deck of cards as an array of integer values of the cards, with an ace always being 1, the number cards being the value on the card, and the face cards being 10. So quite simply, we'll keep drawing cards and adding their values together until we reach a threshold, such as 17 or more, and then we'll see if we came in under 21, got exactly 21 or blackjack, or if we got over 21 or busted. So first, hopefully you see that there is repetition in this problem. We continue to take cards off the deck and add them to our total until we reach our threshold value or higher. We're done when we've reached the threshold value or more. If we were writing this with a loop, we'd have an accumulator variable to hold the total of the cards, and we'd continue looping until that accumulator variable held a value greater than or equal to our threshold value. When we write a recursive solution, there is no loop. We write a recursive method with an if statement. If we've reached the ending condition, called the base case, we return from the method. There might be one or several base cases depending on the problem. If we have not reached the ending condition, then we call the recursive method again, but we reduce the problem when we do that so that we eventually reach an ending condition. This is just like a loop in which we change the loop control variable in the loop so that the entry condition is eventually false. Otherwise, we have an infinite loop. We don't want an infinite loop or an infinite recursion. I've set up a little bit of a solution here so we can focus on the recursive method. I have a main method in which I've defined a deck of cards as an array of integer, and each card is simply the value of the card. Again, I'm counting aces as ones to simplify the problem. Notice there are a lot of 10s because of all of the face cards. I've written a shuffle method that will randomize the array. In a loop, I'm shuffling the deck, calling the recursive blackjack method, and printing the result. This isn't a loop, so we can execute the method several times to see the result. Let's write the recursive blackjack method. We'll start with just public static int recursive blackjack, and we'll pass in the deck. Now, before I talk about what else we might pass in, let's talk about what this is returning. We're going to return the value of the hand, which is the total of all of the cards that we've drawn. So that's an integer. And again, before we talk about what we're passing in, let's think about the method and what it needs to work. The base case is the case in which we are done recursing. It's like the loop entry condition of a loop. When are we done? We're done when the total of the cards we've drawn has reached or exceeded our threshold. So we'll need to pass in the total of the cards. We'll add int total to our parameter list. Are there any other base cases? I suppose if we ran out of cards, but we can put in a precondition that the deck must be a full deck. There are no other base cases. Now, what is the recursive case? That's equivalent to entering the loop. The recursive case is the other case we haven't reached the threshold. We'll draw the next card off the deck, add it to our total, and call the method again. We want to make sure that when we call the method again, we move closer to a solution so that the recursion eventually ends. We end when that total reaches or exceeds our threshold. So by adding to the total, we're moving closer to ending the recursion. How are we going to keep track of the top of the deck? We can use an index and pass that in as a parameter as well. We'll want to increment the index each time we call the method again so that the top of the deck has moved past the card we just dealt. Okay, so that means our method header will look like public static int recursive blackjack, integer array deck, int total, int top for the top of the deck. And then inside, let's set our threshold to 17, which I think is the threshold that casino dealers use, so it's probably statistically the best threshold. And that defines our base case. We'll write if total is greater than or equal to 17, and then we'll return total if so. We're done recursing. We've added up our cards. And then for the recursive case, else, we're going to call recursive blackjack. and pass in the deck, which doesn't change, the total plus the card on the top of the deck, so deck sub top, and then plus plus top to move the index to the next card. Now we're not going to just invoke it, we're going to return it. We have to return a value from this method. The last call is going to return the total, but what about all the calls before we get there? They need to return that total too, so we return whatever the method call returns. Let me invoke the method with the deck as a parameter and literal zeros for the total and the top. And then let's look at it executing in the debugger for just one execution. I'll comment out the loop and put a breakpoint on the first line of our recursive method. And we press the debug icon and agree to switch to the debug perspective, and we're in the method. Notice that total and top are both 0. On the left, we can see the stack with the main method and then recursive blackjack. Now, the base case condition is false. So we go to the recursive case, and we're back in the method. This is a new invocation of the method. You can see on the stack there's a new recursive blackjack, and you can see that total has a value of 3 for this invocation, and top has been incremented. The base case is false, so we'll step again into another recursive call. And watch as we keep stepping that invocations are added to the call stack, and the value in total increments by a random amount, the amount of the next card on the deck, and the value of top increments by 1 each time. And for our final invocation, we busted. We've reached our base case, and we return total. But we're not done returning yet, and this is why we need to return from each invocation. If we returned the total only from the base case, it would return to the prior invocation of the method, but that's not the calling method, that's not main. We need to propagate that result back up through all of the methods back to main. So when we invoke the method on each recursive call, we return what gets returned. In this solution, we can see that one of the parameters is used to control the recursion. That parameter is changed every time we make a recursive call. That parameter is total, the accumulated sum of the cards so far. That parameter is compared to determine if we're in the base case, and then it's modified when we make the recursive call so that the recursion will eventually end. You will always include a control variable or recursion variable like this in the header of your recursive method. Let's look at another example that's similar, but that uses the call stack to accumulate a result. We accumulated into a variable here because we needed that variable to control the recursion. Suppose we want to add the top 5 cards on the deck. We could write the method in basically the same way as we wrote this one. However, we could also write the method so that the result accumulates as we return through the call stack. So let's write public static int addCards integer array deck int top. We won't include a total variable. How does that work? First, think about the base case. The base case is when we've reached the 5th card, which is top equals 4. When we've reached that card, we want to add it to the accumulated sum and return. We'll write if top equals 4, return deck sub top. So where does the adding take place? That takes place in the recursive case. Else, return deck sub top plus addCards deck plus plus top. Let's shuffle the deck and invoke that. We'll need to pass in our deck and then 0 as the index of the first element in the deck. We can also print out deck sub 0 plus deck sub 1 plus deck sub 2 plus deck sub 3 plus deck sub 4 to confirm that our algorithm is producing the correct result. And each time we run it, we get the same result from the hard-coded addition and our recursive addition. So in this sort of recursive algorithm, you are breaking the problem into basically the head of the array, the thing at the current index, and the rest of the array. And our algorithm says, if we're not at the end of the array, add the current thing, the thing at the head of the array, to the rest of the array. Or, in our case, up to the fifth element. And then when we invoke it again to reduce the problem, we move the index along, so the head is the next element. Eventually, the head is the last element, and we're at our base case. Now, a very good resource on recursion is the recursive problem-solving chapter of Java, Object-Oriented Problem Solving, which is a free open-source textbook available on the internet. I'll link it in the description. One thing that those authors bring up is the principle of information hiding. With both of the methods that we've written here, the user of the method has to pass in some control information, which is very dependent on how the algorithm is written. It would make sense to make the recursive algorithm private then, and to create a separate public method that hides that control information from the user of this code. So for example, for the recursive blackjack method, I might write a public blackjack method that takes the deck as a parameter, and have that method invoke recursive blackjack and pass in the 0 for the top of the deck and the 0 for the total. That way, the user is not aware of how the algorithm works, and if we change the algorithm, only our own method is impacted. This is a good practice. There are practice exercises in the description of this video that will allow you to write the two recursive methods we've written here. I recommend you practice with the exercises and then read the chapter that I've suggested and try the practice exercises there. Don't worry if it takes a little practice to think recursively. You'll get it if you persist. Have fun.